Okay, tell me, what questions do you have?
If we can do the point H and I from the last seminar again, please.
What the test of point?
I'm sorry, I can't hear you.
Gaudon, turn off your microphone. Thank you. Just a second. Let me find points that you have told me about. Let me find a list with problems. F, do you hear me?
Yes.
Okay. What point do you want me to solve first? What was the task? To find what? Because I have the points written in a different form in my list. It's not the form that I gave to you at the seminar. So please tell me the task of the first point that you want to solve.
Is OA, OB, OC an orthogonal system? If not, orthonorm it. This is the first point. And the second one is find the attitude of tetrahedron OABC, which corresponds to delta ABC.
First point. How to check if a system is orthogonal? What do you have to check?
The dot product.
Yes. You have to find this product. You have to find first the coordinates of vectors OA, OB, and OC. You already have the coordinates. I'm going to write them here again. So you have 3i plus j, then I plus 2j plus 2k, and I plus 4k. The of the product between OA and OB is
3 plus 2 and plus 0.
yes, which is not 0. So, see, you can use the fact that this system is not an orthogonal system. But let's compute the other dot product because maybe, I don't know, we will find two vectors which are perpendicular and we will use them to orthogonalize system. So OA in dot product with OC is
Oh, 3 and plus 0 plus 0.
and the last one?
And 3 plus 0 plus no, yeah, plus 0 plus 2 times 4.
So, so that's it. I'm so sorry. My internet connection is very bad, so I have tried another method to connect to the internet. Just a second, let me share my screen. Okay, so from these facts, we deduce that S is not an orthogonal system. How do you orthonorm S?
We apply the Crashbit procedure.
Exactly. The first vector, the first new vector of our set will be OA, the first vector of this set. Then the second vector will be constructed using OB. So this is OB minus the projection of OB. And last is
It's OC minus the projection of OC on V1 minus the projection of OC on V2.
I'll 2 minutes to find V2 and then we discuss. Okay. Have you found V2?
No, we need to additional time.
Okay. How do you start to compute V2?
So we need to find out the projection,
Exactly.
which is 5/9 multiplied by V2.
Let's see. Let's see. So OB is I plus 2J plus 2K. Yes, minus. And the definition of the projection is
V1 OB
yes. In this
upper
case, we can write in this way. Upper V1 times
V2. No, V1.
V1, which is I plus 2J plus 2K minus, let me write that because I don't have so much space. OB and V1. OB and V1 means OB and OA in that product, but you already have OA and OB in that product computed, so this is 5 over V1, this one times this one, which is 1 squared plus 2 squared plus 2 squared, right? So it's 1 plus 4 is 9, exactly what you've told me, times V1, which is 3 plus J. So we have that 2 is equals to 3. Minus 1 over 9 times I plus 3. So this means I minus 5 over 3i from here, yes, from this multiplication, plus 2j minus 5 over 9j from here, plus 2k.
I have a question. Why is 5/9? Lost that.
Yes, is not 5/10.
Isn't it 5/10? Because it's 3 times 3 plus 1.
I get wrong.
So, sorry, I was looking at OB. Sorry. Exactly, yes.
I made this mistake first time.
Yes, indeed. Sorry, I was looking here. Yes, thank you for correcting this computation. So you have 9 plus 1 is 10. Yes, yes. So this is 10. Indeed. So let me write it this way. Here, 3 okay, and 1. Yeah. So V2 is minus 1 over 2i. This one is 3 over 2j. And the last one is 2k. Okay, thank you again. And this is V2, but I told you that when you have fraction, the best way to continue computations is to consider a vector which is multiplied with a constant, such that in the end you won't have fractions here. So you know that V2, let me draw a smaller V2, this one. You know that V2 is perpendicular on V1. This V2 is perpendicular on V1. But in order to obtain numbers, you have to multiply V2 by 2. And you know that if you multiply a vector by a number, you will get a vector which has the same direction as the first vector. So this is the vector 2v2. And this will be also perpendicular on v1. So instead of working with fractions here, I'm going to multiply this vector by 2. And I will choose v2 to be this one, minus I plus 3j plus 4k. Because in this way, it's easier for me to make the computations, and also I have a vector which is perpendicular on v1, so it's fine. If you don't trust me, make the product between v1 and v2, and then it is so v1 is 3i plus j, and this v2, this new v2, is minus I plus 3j plus 4k. Okay, so you have 3 times minus 1 plus 1 times 3, which is 0. My advice for you is to check each dot product after you find the vector. So you have found V2, okay, compute this dot product between V1 and V2. Because if this dot product is not 0, it means that your computations are wrong and you must compute again V2. If you continue to work with a vector which is not correct, then the computation won't be correct. Okay, so if you make a mistake, you will be able to check if your vector is correct here. If not, you have to come again here and to check the computations. Okay, this was V2. Let's see V3. V3 was OC minus the projection of OC onto V1 minus the projection of OC onto V2. Okay, and OC was R plus 4K. So, this is R plus 4K minus the projection is given by OC in that product with V1 over V1, V1 times V1, this one, and the other projection will be OC V2, okay, over V2 times V2 is this one, V2 is this one, and OC is this one. So I will give you 3 minutes to find this vector V3. Have you found?
Yes.
Okay, let's see. Is I plus 4k minus, let's pay attention, OC and V1. OC and V1. Okay, so you have 3 plus 0 over 1 against 10 times V1, which is 3 plus J minus OC V2, this one. So you have -1 plus 0 plus 16. Okay, and V2 means 1 plus 9 plus 16 times V2. I think this way. 9 over 10I minus 3 over 10J. And this is 15 over 26 plus I minus 3 times 15 over 26 J and minus 15 over 26 times 4K. Okay, have you made the computations until the end? So you will have 1 minus 9 over 10. Okay, it's 1 over 10 plus 15 over 26I plus, so from here, here, and here, plus times this one, plus this one, right? So plus J times minus 3 over 10 plus minus 45 plus 8 times. K appears just here and here. So you have 4 minus 15 times 2 over 13 because I have a simplification here. And you have to make these computations to see the final vector. And after that you find the final vector, you will have to find the norm of each v and to divide v by its norm. So for v1, you will obtain another vector w1, which is actually 1 over norm of v1 times, and v1 is v1 which is square root of that. Then from v2, you will have w2, which is 1 over the norm of v2 times v2, okay, which is 1 over the norm of v2 is 26, so you have a square root here, square root of 26 times for v3, you have to apply the same formula. And you have to compute the norm of v3 and v3. Okay, so in the end, S prime, which consists of W1, W2, and W3, will be an ortho-normed system. But after you find here V3, make sure that V3 is perpendicular to V1, so compute this dot product, and also compute the dot product between V3 and V2 to make sure that V3 is perpendicular on V2. So after you find this vector, please make these computations to check if V3 was found correctly. Okay, and after that you find W1, W2, and W3. Do you have questions? Oh, so let's do the second one. find the altitude of the tetrahedron, which is formed with O, A, B, and C, where of course O is 0, 0, 0. And this altitude must correspond to the triangle ABC. Okay. Let's see. First, let's make a picture. Let's say that this is O, this is A, this is B, and this is C. And this is the tetrahedron OABC. Let's denote the length of the altitude by h. Okay, so we want to find h. You know that the volume of OABC is given by the following formula. This is the area of the triangle ABC times the altitude. So if you want to find the altitude from here, first you have to compute the volume of OAC, and then you have to find the area of the triangle ABC. How do you find the volume of OABC? Actually, we have found it in a previous point, which was solved at the seminar. How do you
It's 1/6 multiplied by the mixed product.
find it? So times you should put a module because that mixed product can also have a negative value. And you have OA, OB, OC. Okay, and this was equal to 22, if I'm not wrong.
Yes, 22.
Thank you. Then find area of the triangle AB. Which product helps you find area of triangle or of a parallelogram? Okay,
It's the X product.
so repeat. And can you repeat? Andrea, I didn't hear you well.
Sorry, I couldn't hear you very well.
I have a problem with my internet connection. How do you find area? What product is used?
The X product. I forgot the
Yes.
product.
Yes, exactly, the cross product.
Yes, that one.
So this area is 1/2 times the norm of AB cross product with AC. You know that if you have a triangle ABC, then the area is AB times C times sine of A over 2. And this is actually norm of the vector AB times norm of AC, because the norm is the length, times sine of A, which is actually the norm of AB cross AC over 2. Okay? I will give you 2 minutes to find this norm. Have you found this area? Have you found first the cross product of AB and AC? How AB looks like?
Is it minus 2i plus j plus 2k?
See, it's AB plus SA plus YB minus YA J, and the same for Z. And let me take a look at the points. So A was 3, 1, 0, B was 1, 2, 2, and C 1, 0, 4, right? So we have minus 2i exactly, plus j, yes, plus 2k indeed. Okay, and then AC is
minus 2i minus j plus 4k.
okay. You have 4 plus 2, which is 6. Okay. Then minus 8 plus 4 is minus 4 with a minus is 4. And minus 2, oh no, sorry, 2 plus 2 is 4. So you have 4k, right? Have you obtained the same result?
Yes.
Okay. So the norm of AB cross AC is square root of 36 plus 16 plus 16. 68. Okay, so you know that the volume is the area times the altitude over 3, and this is equivalent with 11 over 3 equals, this is actually 2 times square root of 17, right? So the area of the triangle ABC is this one over 2, so square root of 17. And this is square root of 17 times h over 3. So h is this. And this is the answer. Okay, do you have questions related to this solution? Okay, so if you don't have questions, tell me what other questions do you
I find the problem. Can I ask
Yes.
about it?
Yes, sure.
Okay, so has multiple subpoints, and I will ask only one.
Can you repeat, please?
It has multiple subpoints from A to E, but I will ask only one because if you get one, the rest is easy.
Okay.
Let be given the application A, V or V on R.
So A,
Yes.
the right? Okay.
And you get A of P and Q
Yes.
equals to integral from 0 to 1
Yes.
pt dt
P T.
yes times integral from 0 to 1 qs ds, and the pq are polynomials from R2.
Okay, so f is r of x. Yes, and PQ r from V. So it means that
Is given a base as well.
okay, just a second. P of x is let's say P x squared plus P of x plus P zero, right? So let's
Yes.
take this one, and Q of x is Q2x squared plus Q1x plus Q0. Okay, I want you to say it from the beginning of P and Q. Okay, and now tell me the test.
The base is Q1 equals 1 plus Q.
So 1 plus Q, okay, and
1 plus X, sorry.
1 plus X,
The
yes,
base is X squared and 1.
X squared and 1. So the question is this a base? No,
No,
this is a basis.
this is from the statement.
Okay, this one
know
is a basis, let's say B1, right?
Yes.
Yes, you know that this is a basis of R2 of X. Yes, and then?
Okay, so some of the question are, let's say, find the associated matrix to the quadratic form of this bilinear form.
Yeah.
And the other one is find care of A and rank of A, and to check the dimensional theorem.
Care of rank
of A.
Okay.
And the other question from me, it will be for the positive and negative defined. It's to find if it's positive or negative defined. If it's
Okay, find the matrix A.
yes,
Is A positive or negative defined? Let's see. But here the matrix A must be written with the basis B1.
yes.
Other questions, other tasks, or just these 3 tasks?
Just this, because the first one is to find out if it's a bilinear form.
Okay. Okay. How do you write a matrix of a linear map with respect to grades?
It's B1 transpose times the matrix or B.
So we suppose that A is already a bilinear form, right?
Yes.
Because if you don't have this fact proved, then you won't be able to solve easily the other questions. Okay, so let's suppose that A is a bilinear form and you want to find the matrix. But first, you have to find the form of A. Okay, so you have to find the explicit form of A. So P looks in this way and Q looks in this way. How A of P and Q will look like? I will give you 3 minutes to tell me how A of P and Q looks like. Okay, so replace P of T by P2T squared plus P1T plus P0. Replace Q of S by Q2S squared plus Q1X plus Q0. And then please make these computations in order to find the form of A. Because if you don't know the form of A, you won't be able to write the matrix. Okay, 3 minutes. Have you found formula A?
Yes.
Okay, let's see. So A of P2 x squared plus P1x plus P3 and Q2x squared plus Q1x plus Q2 is in of 0 to 1 from this one. Let me write the x because the variable doesn't matter actually. I can write with no problems the same variable here and here. Okay, so this is P times 1 over 3, right? Plus P1 times, this is x squared over 2, which is 1 over 2 if you replace x by 1 and 0, plus P0 times the same. And I need partners. 1, 2, 3, use 2, 3, right? So A of this polynomial is this one. Did you get the same expression?
Yes.
Okay, that's perfect. So in order to write matrix of A with respect to this basis, you have two methods. You can write directly the matrix by replacing P and Q with 1 plus x, x squared 1, and so on. Or you can write from here the matrix of A associated with respect to the canonical basis, and then you have to write the change of basis matrix from the canonical basis to B1, and use the C minus 1 times A times. Okay, so you have two methods for the matrix. But let's find this matrix directly. So let's replace P and Q by these expressions, by these polynomials. But let me write them in an order. Let's start with x squared, okay? X squared because it has the degree 2, x plus 1, the degree 1, and then 1. So if you want to find the basis, you have to replace first P and Q by x squared, okay? And you have to compute A of x squared and x squared. So it means that P2 is 1, Q2 is 1, and the rest of them are 0, right? So you have just 1 over 9, P2, Q2, because they are 1. So this is 1 over 9. And in my matrix, if it's x squared, x1, x squared, x, oh no, x plus 1, x plus 1, and 1, then the coefficient of x squared and x squared will be 1/9, this one. Then take a look at a of x squared and 1 plus x. When you compute this one, you have that P2 is 1, then 0. The rest of the elements are 0 here. And then here Q2 is 0 and Q1 and Q0 are 1. So you have to compute this A using this formula, or if you want, you can compute it from here directly. It doesn't matter. Let's compute it from here because I don't have this formula on the page. So this is times this. Okay, you can compute it using every time. So if you don't like it. So this is 1/3 times, and this is 1 plus 1/2. Because this is x squared over 2, which is 1/2 in the end. Okay, so this will be actually 1/3 times 1. Let's put that 3 times 3/2, which is 1/2. Okay, and 1/2 is the coefficient of x squared and 1 plus 6. So 1/2 will be put here. 1/2. And because A is a bilinear symmetric form, then A of 1 plus x and x squared is the same with this one, so it is 1/2. So it means that in this matrix, you put 1. Then you have questions.
We can use this method anytime. Let's say if we get a base to compute the without the change of basis metrics. Or
You can use this in order to compute this matrix, but the idea is the following. When you get this result, you must express it using the basis which is given to you. So let me write in this way. I don't think that my writing here is so explicit. Let me write in the following way. So the idea is the following. I want to find the matrix of A with respect to the basis B1, which will be denoted by A prime. And matrix of A with respect to B0, where B0 is the canonical basis. Where B0 is the canonical basis, okay, is denoted by A. And the change of basis matrix from B0 to B1, B0, B1 is denoted by C. But CB0, B1 is the matrix in which you put the elements of B1 here using the canonical basis. So this will be the first polynomial of B1, the second, and the third. And you have that this prime is C at -1 times A times C. Okay? And you have two methods. First method consists of writing directly the matrix A prime. And the second method consists of finding first the matrix associated with the basis. So first you find, you have to find the matrix C, which consists of the elements of B1. And then if you want to find this matrix A prime, you have to compare C at minus 1. So if you know C, you have to find C at minus 1 and to make this multiplication. How the matrix C looks in this case? How C looks in this case?
It's a symmetric matrix.
C the matrix from the base B0 to B1. The canonical basis here consists of x squared x and 1. So B1, which is this basis, I don't see it, is here. B1 is actually something which comes from the canonical basis, but it has some additional elements. So you know that the first element B1 is x squared, which is exactly the element of B0. So you will put here 1, 0, 0. Okay, because x squared from here, from B1, is 0 times x squared from the canonical base plus, is 1 times x squared plus times x plus 0. This is 1, 0, 0. Okay. 0. Then x plus 1 from P1, x plus 1 from here is 0 times x squared plus 1 times x plus 1 times 1. So this is 0, 1, and 1. And 1 from here is 0 times x squared, 0 times x plus 1 times 1. So we have 1. Okay, so let me write in this way. X squared from here is this one. X plus 1 is this one. 1 is this one. And these elements are x squared, x, and 1. So you have to express the elements of the new basis with respect to the canonical basis. Okay, and this is why you obtain this matrix C in this way. Is this matrix C a symmetric matrix?
Yes.
Take a look here. 1 and 0.
No, actually no.
But is C an orthogonal matrix?
Yes.
What does it mean? What is an orthogonal matrix?
The vectors in the matrix would have the dot product 0. But between the second and the third is not the rule, so we have to orthogonize them.
Just take the transpose. Sorry, take the transpose of C. C transpose is 0, 0, right? 0, 1, 0, and 0, 1, 1. And compute C transpose times C. Take a look at what you get from here. I will let you to C transpose times C. What matrix did you get?
The unit matrix.
Yes. And if you will compute C transpose, you see that you get matrix. So it means that C transposed is C at minus 1. So you don't need to compute C at minus 1 by finding the adjoint matrix and so on. You will see that C at minus 1 is exactly C transposed. So A prime is C transposed times A times C. Okay, so let's come back to the questions that you put me, Janan. Your question was, how do I find this matrix? And I've told you that you have two ways. First way is to find directly this matrix, as I did in this case. So I computed A of x squared and x squared, and I took every element from this basis B1, and I have made all the possible combinations between them, and I have started to compute each element, and each element must be put in a matrix. Or if you want to find the matrix in the canonical basis first, you have to use these elements, x squared, x1, to find each combination of 2 by 2 elements, and then you get the matrix with respect to the canonical basis, which is this capital A. And then you write the matrix C from B0 to B1. You see that C at minus 1 is C transpose, so you already have C at minus 1, and you just have to multiply C transpose with A and C to get this matrix A prime. So you have two methods. You can use to the right. It doesn't matter. Did I succeed? Explain what you understand?
Yes.
Explain something else. Do you want me to explain something else here?
No, it's good. It's good.
Okay. We won't make all the computations, but you get, yeah.
Yes.
Okay. So if you don't like to work with this formula because it may seem complicated at first, then let this definition and use the input of each element that you have here. This is more simple to it, and this way to compute A of it. Then my question is, of course, the definition of the kernel of such a bilinear form?
No, I think it was not supposed to ask this.
Because the definition of the kernel in this case is a little different from the definition of the kernel of a linear mapping.
No, I'm sorry,
Yeah.
I get wrong the request. So
It's fine. But for linear mappings, we have T defined or not T, A, let's say A. So if you have A defined on V with values on V a linear mapping, you know that the kernel of A makes all these, so let's say X from V, such that A to X is not vector of V. Okay, all the solutions of this equation. If A defined on V cross V with values in R is a symmetric bilinear form, then the kernel of A is defined as the elements X of having the property that A of X and Y is 0, 0 as a number, for each Y in V. Because you have two arguments here, and this is why the definition is modified. So I think that you haven't seen this definition of the course, right?
Yes.
Okay. In order to find the kernel, you have to do this condition. And have to solve this equation. Y can be any polynomial in R2 of X. So it's a little complicated, but let's skip this point. How do you check if A is positive or negative defined?
So if you have the matrix, all the minors have to be positive, defined, or but I have a question here because if all the minors are negative, what will happen?
Yes. If all the minors are negative, then just a second. A is positive defined if this is the definition. If A of X and let's say Y is how? Where Y is X actually. A of X and X is how? Is greater than 0 for every X different from the number of V, right?
Yes.
Okay, because if X is 0 V, you get 0. Okay, A of 0 and 0 is 0. And A is negative defined if A of X and X is less than 0. But it doesn't mean that all the bilinear are positive or negative defined. So if A is a bilinear form, A can be positive defined, negative defined, not positive, not negative. So you have to use the minus, but when all the minus are positive, you have a form which is positive defined, right?
Yes.
Okay, when the first minor is negative, the second one is positive, and the last one is negative. You have something which is
Not positive, negative defined.
Negative defined, exactly. And when all the minors are negative, you have something which is not
Not positive,
positive,
not
not
negative.
okay. You have this function. It kind of function. The function is even or odd, or not even and not odd. So in this case, when you have all the principal minors negative, you have not positive, not negative, and this is the answer. This is the definition, but if you want to check if A is positive or negative, you could check principal minors of values. If values are positive, you have to use form which is positive defined. if the values are negative, you have a linear form which is negative fine. And if you have positive and negative values for large, which is positive and negative. Okay.
I'm sorry. Could you repeat because I couldn't hear anything?
Okay. So I told you that if you have A, which is the matrix of A, this matrix has some minors. This one is the minor of order 1. This one is the minor of order 2. This is delta 2. This is and delta 3 is that of A. If delta 1, delta 2, delta 3 are positive, it means that A is positive defined. If delta 1 is negative, delta 2 is positive, delta 3 is negative, A is negative defined. And colleague asked me what happens if delta 1 is negative, delta 2 is negative, delta 3 is negative. It means that A is not positive and not negative defined. Okay, get it? Corina, do you understand what I'm doing here?
Yeah, I understood better this time.
Okay, but for the second case, it can start with delta 1 positive and then negative. It only needs to be alternating, no?
Alternating with the first one negative. It is mandatory.
Oh, is mandatory to start with negative
Yes.
delta 1.
Yes.
Okay.
Yes.
Okay.
Where these are the eigenvalues? It is mandatory because remember when you use linear calculus at mathematical analysis.
Yes, you used
Where?
for the extrema points.
Yeah, exactly. For the extremal points. And the Hessian matrix of a function f behaves like A. And this A is actually the differential of order 2 of the function. And you have to compute some minors and to check their signs. Okay. So this is an example of application of linear form in mathematical analysis. And is the same theory here and here. This is why to obtain delta 1 negative and then positive and then negative to have a negative defined bilinear form. Okay, what other questions do you have?
I have a question.
Please.
Oh, 1 second, let me find it. It's a matrix, then we need to find the basis form with the principal vectors. And at the last principal vector, I didn't find it correctly, and I don't know why.
Okay,
Uh,
from a seminar posted on Moodle.
yes, it's from Moodle,
Then
from Seminar 8, exercise 2, problem C.
Second, let me access Moodle to open the seminar. Can you repeat, please, the number of the seminar?
Seminar 8, I think. And let me check real quick to be sure.
Just a second. For which you this
Here, exercise C.
to see
Yes.
to see. And see what in this case you cannot analyze the facts because in this case you have MMG less than MA. So what have you solved? Let's see. Have you found the eigenvalues?
Yes, I found the eigenvalues and the eigenvector V1. And using
Okay. So you have found, just a second, let's write seminar 8, problem 2C minus 2. Okay, the eigenvalues are lambda 1 equals, what is the found here? Lambda 1 is
lambda 1 and lambda 2 and lambda 3 are all 2. Well, lambda 1 is
okay.
2 and has a multiplicity 3.
Okay. And you found an eigenvector, which is 1, which
1 second, so I can find it. V1 is where did I write it? Oh, 2, 0, and 1.
okay. So it means that one is 1. And you have to find two principal vectors, okay? Because in your basis, you just V1. And you need two more vectors, V2 and V3. You don't know them, but they are called principal vectors. Okay, it's clear that in this case, MA is not MJ, so A does not admit diagonal form. It admits Jordan form, but you will see next year what is Jordan form. Oh, and your question is, how do I find V2 and V3, right?
I found V2 and V3, but V3, I couldn't manage to write it using V2. I managed to write it using V1, and I don't know if it's right or not.
Okay, let's see. If you find 2, you have to apply the formula lambda 1 3 times 2 equals V1. Okay, if you want to, and it's ABC. And this is this one. Subtract the 2 on the main diagonal, you get 0 minus 2, 0. 1, 2 minus 2, 1, 1 minus 2 times ABC. equals to 1. Right? Was this the form of first principle factor?
Yes.
Okay, and you must choose a constant C because C is something real. You see that this is actually V1. Okay, so V2 is a vector plus a constant times V1. Let's take C equals 0, but you can take C equals 1 or what any other value you like. So for C equals 0, you get that V2 is 2 minus 1, 0, is this one. Okay, and now if you want to find V3, you must use a formula which is similar with this one, but you put here V3 and here V2. So you have A minus lambda 1 I3 times V3 equals V2. You get the same expression here.
Yes, but I was wondering, don't we need to have C times V2, not V1? Because I got the
No.
same.
No,
Oh,
because V1
V1.
is your eigenvalue. Eigenvector, sorry.
Oh, so we need the primary eigenvector that we got from the eigenvalues. I understand now.
Yes, so V1 is an eigenvector, is the only eigenvector. So all the principal vectors will depend on this V1, which is the only eigenvector. So it's okay. This is the first way, and this is one of the ways in which you can choose three. But here it's V1 because V1 is the only eigenvector.
I understand now. I thought I had to get V2, not V1. That's why I
No,
asked.
no, it's okay to have V1 there.
Thank you.
Welcome. What other questions do you have? What questions do you have? there is something for seminar that you understand or what we have talked here today?
Maybe we could do an exercise with the quadratic form, though I don't really have any exercise to propose.
The problem quadratic forms that you could have at the test are the problems in which you have a quadratic form and using the eigenvalues and eigenvectors method, you have to find the canonical form of that quadratic form. So this is the only type of problem that you could have at the seminar, but let me take a look on some examples because if I tell you an arbitrary quadratic form, I might obtain some eigenvalues which are not so nice. And I must choose carefully a quadratic form because the idea is to obtain some eigenvalues which can be computed easily.
I have some example if it's needed.
Please.
I don't know, let's say. We can put this. Q of x
Yes,
equals minus x1 at power 2 plus 6 x1 x3 plus x2 at power 2 plus 4 x2 x3 minus 5 x3 at power 2.
okay. The eigenvalues and eigenvectors method.
Do we only need the eigenvalues method for the exam?
Yes. Okay, what is the first step? What do we have to do first?
First of all, you have to find the matrix.
Yes. Tell me first the elements on the main diagonal.
On the main diagonal, you have minus 1, 1, and minus 5.
Yes. Here.
Of 0 and 0 because the terms are
Exactly.
missed.
Exactly. Because you don't have x1, x2 here. Then here and
3 and 3.
yes, because this is 6 and you have to divide by 2. And here and here.
2 and 2.
From 2 and okay. You should find the eigenvalues. Okay, I'll give you 3 minutes, solve this equation and find the values. Have you found the eigenvalues?
Not all of them, but
Okay, let's see what you have until now. So you have that
determinant, it's if I compute it correctly, it's minus lambda.
minus lambda minus 1. Let's see. Let's compute together this determinant. So you have 1 plus lambda times lambda minus 1. Okay, minus lambda plus 1 plus times 5 plus lambda. Let's write in this way. From here, here, and here. 0, 0. Minus 9 times 1 minus lambda. 0. And from here is plus 4 times 1 plus lambda equals 0. Don't make the computations here for the moment, because it might have something as a common factor. So you have minus 9 plus 9 lambda plus 4 lambda. Well, you don't have a common factor. Because you have minus plus 31. No. So you have to make the computations here, and you get 1 minus lambda squared times 5 plus lambda. Okay, is it correct? So you have this one plus 0
Yes.
plus 0. Minus 9. So it's correct. So we have to make some computations here. So you get 5 plus lambda are they? So the product is minus 14 and the sum is minus 5. Okay, it's correct. Yeah, so it means that actually Q of x will be lambda 1, let's say x1 prime squared, plus lambda 2 x2 prime squared, plus lambda 3 x3 prime squared. So this is 0 minus 7 times x2 prime squared plus 2 times x3 prime squared. And this is the canonical form, but also you have to find the basis. And the basis consists of orthonormed eigenvectors. So the basis is formed with vectors having lambda 1, lambda 2, lambda 3, which are different. It means that V1 to V3 is an orthogonal system. Because that the eigenvectors corresponding to different values are orthogonal, so they are independent. Okay, and these are eigenvectors. So after you find the eigenvectors, having already an orthogonal system, all you need to do is to divide each vector by its norm. So W1 will be 1 over the norm of V1 times V1. W2 will be 1 over the norm of V2 times V2. And W3 is 1 over the norm of V3 times V3. Okay, so B prime is W1, W3. So after you find the eigenvectors, you will check that they are orthogonal by checking the fact that lambda 1, lambda 2, and lambda 3 are different. And then all you have to do is to compute the norms and to divide each vector by its norm. And this is it. Homework to find the place of people. Okay, so your properties. Because we have already seen a lot of examples with eigenvectors of the standard.
Okay, but if in the exercise it says, let's say we get the base where you have to find the orthonorm eigenvector basis, we only need to verify if it's orthogonal, and if it's not, to orthonormalize it, no?
Yes, but they will be orthogonal vectors. I mean that they will be perpendicular to by because lambda 1, lambda 2, and lambda 3 are different, and all you have to do is to divide each vector by its norm to get a vector of norm 1. For example, if you had lambda 1 equals 0, lambda equals 0 again, and lambda 3 equals 2, then for 0, you would have V1 and V2. But having the same eigenvalue here, 0 and 0, you have V1 and V2 not necessarily orthogonal vectors. So for V1 and V2 correspond to the same value, you have to orthonorm them using Schmidt procedure. But if they correspond to different values, they are always orthogonal vectors. So all you have to do is to orthonorm them to make them to the norm 1. Just this. But if they come from the same value, you have to obtain first perpendicular vectors and then to norm them. This is the idea. What other questions do you have?
It's a simple question, but what would be the algebraic multiplicity of lambda 1, lambda 2, and lambda 3?
Because you have an equation of degree 3, and you have 3 different solutions. Each one is solution 1. So the algebraic multiplicity of lambda 1 is 1, the algebraic multiplicity of lambda 2 is 1, the algebraic multiplicity of lambda 3 is 1. What other questions do you have? Okay, so if you don't have questions, thank you for participation. I will post this whiteboard module and see you tomorrow at the test. Have a
Thanks.
nice
See you
day.
tomorrow.
Thanks. See you.
Okay,
Bye.
see you tomorrow. Thank you.
Goodbye.
Bye.
Goodbye.
Bye.